2 lessons ago, we learned about double replacement reactions. Now we're going to take it one step further and look at net ionic equations. So these are the same exact equations that we had before. So I'm going to really quickly just review double replacement reactions again. So double replacement was when you wrote the charges for each one, and then you switch the two positives. So okay, NO3 goes here, and then PBI2 because PB is 2 plus goes here. Then you write the states. This one was aqueous, this one was solid, and then we balanced it. Okay. So from this step, now we're going to write something called a net ionic equation. Remember, the solubility chart is only for your products. For your reactants, if the states are not given to you, you're always going to assume it's aqueous. This is only for double replacement reactions. So double replacement reactions, if the states are not given to you on the left side, then it's going to be aqueous. Now, for net ionic, what happens is if something is aqueous, so if I put PbNO32 into water, what happens is the Pb and the NO3, they come apart, and then it becomes charged, and this is what causes electricity to be able to run through the water because we have positive and negative ions. So we're going to write the equation the way that it will look inside of a liquid. So PbNO3 is put into here. The Pb and NO3 come apart. When they come apart, the charges are going to follow it. So Pb has a charge of 2 plus, and then plus NO3 has a charge of 1 minus. But we see here, we have a 2 here. So to say that there are 2 NO3s, you're going to bring that out in front. So we have 1 Pb and 2 NO3s. So plus, this is also aqueous, so it comes apart. So how many Ks do we have here? We have 2 Ks. And so I'm going to write 2 in front of the K and make sure you write the charge because it's aqueous. Plus, and then we have I, but we have 2 I's as well. So we have 2I. So that's what's going to look on the left side. On the right side, again, we have 2 Ks, so 2 and then K plus, plus. And then how many NO3s do we have on the right side? We have 2, so we have 2 NO3s. And then if you notice here, this PbI2 is a solid. If it's a solid, it does not come apart. So I'm going to write PbI2. But if it's not aqueous, you need to write the state there. So I have a solid, that's my state. What you wrote down here, this is called the complete ionic equation. Okay. I want you to take a look at all the ions on the left side and right side of the arrow. What ions are the same from the left side and right side? The same ones are NO3, 2NO3, and then 2K and 2K. So the ones that are highlighted, these are called spectator ions. These spectator ions, they're in the container, but they don't contribute to making the solid. So then these, you're going to cross out, and then you're going to write the equation again. So I want you to write the equation again, but without the spectator ions. So now we have Pb2 plus 2I minus becomes PbI2 solid. And this right here is my net ionic equation. Okay, I want you to take this one right here and go ahead and see if you can remember what the products are going to be and then balance it. So again, really quickly, because we've done this already. So write the charges. The 2 positives will switch places. And then you're going to write the states. And even though down here it says that sulfates with are going to be aqueous, we added Ag onto this list last time. So actually Ag with SO4 is going to be a solid. And then we want to balance it. We have 1 Ag, 2 Ags, so 2 goes here. Then we have 2 NO3s, 1 NO3 here, so 2 will go here. Then we have 2 NAs, 2 NAs here, and then everything else is balanced. From here, we know that on the reactant side, these are going to be aqueous. Now I want you to, on your own, tell me what the complete ionic and the net ionic equation for this would be. So if it's aqueous, it comes apart. So we have 2Ag and 2NO3 minus. This one, we have 2 NAs, so the 2 comes out in front. And then SO4 has a charge of 2 minus, don't forget to write that. This 4 does not come out in front. This 4 is a pi atomic ion. So it sticks together, arrow, and then we have 2 NAs. Don't forget to write the charge. And then we have 2 NO3. And then because this is a solid, it's going to stay together, and you're going to write solid. You want to look on both sides to see what's the same. Our sodiums are the same, and then our nitrates are the same. So these are the ones that are going to cancel out, and then what's left over is your net ionic equation. So there's your answer.